Hello Primary 5, welcome to our session. Today we will talk about factors or multiples. Let's see, factors are numbers that when multiplied by each other give us an answer. This answer is called the product. 1 multiplied by 8 is equal 8. 1 is a factor, 8 is a factor, and the 8 after the equal sign is called a product. Also, 2 multiplied by 4 is equal 8. 2 is called a factor, 4 is called a factor, but the 8 after the equal sign is called the product. Now, the factors are 1, 8, 2, 4. Rearrange them from small to big. So my factors of 8 are 1, 2, 4, 8. How to find factors of a number? If we have 10, think about what numbers multiplied by each other give you 10. Easy. We have 1 by 10 and 2 by 5, right? So we will take these numbers, 1 multiplied by 10, so 1 and 10, 2 and 5. Rearrange them from small to big, 1, 2, 5, 10. Another example, 9. Think about numbers multiplied by each other, give you 9. 1 times 9 and 3 multiplied by 3. Now, factors are 1, 9, 3, 3. When you have 2 repeated factors, take only one of them. We have here both 3 and 3. We will take only one 3. So, my factors are here 1, 3, 9 after rearrangement. If I have 18, think about what numbers multiplied by each other give you 18 from the timetable. Easy. We have 1 by 18, 2 by 9, 3 times 6. My factors here 1, 18, 2, 9, 3, 6. Rearrange them from small to big. 1, 2, 3, 6, 9, 18. If I have 42, 42 is a really big number. How to find its factor easily? Think about first from the timetable. If you have a numbers from the timetable, yes, we have 1 multiplied by 42, yes, and 6 by 7, that's it. Let us discover how to get the rest of factors. 42 can be divisible by 2. We will check by long division. 42 divided by 2. 2 divided by 2 is 1 and 4 divided by 2 is 2. Yes. 2 multiplied by 21. 2 multiplied by 21. These are factors of 42. 42 divided by 3. We will use a long division problem. 42 as a dividend inside, 3 as a divisor outside, multiple of 3, count by 3, 0, 3, 6, and so on. We need exactly 4, there is no 4, so we will take a number close to 4 but smaller than it. 3 at which number? 0, 1 at 1 up. Now drop 2. After subtraction, we have 12. 12 at which? 0, 1, 2, 3, 4 at 4. Yes, 14. 3 multiplied by 14. There is no factors at 4 and at 5. How do I know to get the rest of factors according to divisibility rules. See, if the number divisible by 2, this number should have in its ones an even number. Do you know the even numbers? Yes, 0, 2, 4, 6, 8. 42. 42, its ones digit is 2. 2 is an even number. So whole 42 can divisible by 2. We can use long division to get our quotient. Okay. 3. If the sum of the digits of the number is a multiple of 3, 42 is consists of 2 digits. 2 in ones, 4 in tens. Make plus between them. 4 plus 2 is 6. 6 is exist in timetable 3 or is a multiple of 3. So 42, the whole 42 can divisible by 3. We can get our answer by the long division. It was 14. 4 is a multiple of 4. If multiple of 4 means count by 4 every time add 4. When you count by 4, you will get 42? No. So 42 can't be divisible by 4. 5. We need the ones digit is 0 or 5. 42, its ones digit is 2. Not 0 and not 5. So 42 can't be divisible by 5. 6, the same rule, if the number divisible by both 2 and 3. Yes, 42 divisible by 2 and divisible by 3. So this number divisible by 6. Yes, we know from the timetable 42 is 6 by 7. Yes, we know it. Divisible by 9. The same rule of 3. Magic plus. 42 consists of 2 digits, 2 in the ones, 4 in the tens. Make plus between them. 4 plus 2 is 6. 6 is a multiple of 9 or exists in the timetable 9? No. So the whole 42 can't be divisible by 9. 10. We need the ones digit is 0. 42 has 0 in the ones digit? No. So it can't be divisible by 42. By 10, sorry. Okay. Now, we will talk about multiples. Multiples means count by. Skip count. Multiple of 3. Count by 3. Every time add 3. Start from 0. 0. Add 3, you will get 3. Add 3, you will get 6. Add 3, you will get 9, and so on. Multiple of 5, count by 5. Every time add 5. 0, add 5, it will be 5. 5, add 5, it will be 10, and so on. 5, 10, 15, 20, 25, and so on. Multiple of 15, every time add 15. 0, add 15, get 15. 15, add another 15, it will be 30. 30, add 15, it will be 45. 45, add 15, it will be 60. 60, add 15, it will be 75, and so on. Okay? So, factors means numbers multiplied by each other, but multiples count by. So 0 is a common multiple and 1 is a common factor. To solve the problems, you need to decide this need GCF or LCM. GCF, these problems usually involve, in the story problem of it, words like dividing, distributing, equally, cutting into pieces, or breaking it, something into groups. When you see any word of this, you will solve the problem by GCF. But LCM usually involves something repeated, multiple items, or when two things occur at the same time. We will see together. Omnia has two strips of cloth. One is 35 centimeter wide and the other is 75 centimeter wide. Okay, she wants to cut both pieces into strips of equal width that are wide as possible. How wide should she cut the strips? Do you have to find GCF or LCM? We have here a word, key word here is cut. Cut, GCF. Cut, dividing, distributing, sharing, whatever. So we will need to find the GCF of 35 and 75. We will write them down, 35 and 75. Now, 35, think about what numbers multiplied by each other from the timetable give you 35. Yes, 5 by 7. 75, 5 by 15. Okay, 5 here is a prime and 7 also is a prime. Okay, now 75, 5 is a prime. Do you remember prime numbers? 2, 3, 5, 7, 11, 13, and so on. 15 is not prime, so we will break it into two numbers multiplied by each other from the timetable, give us 15. 15, yes, 3 multiplied by 5. Now we will write again 35 and 75 with its prime numbers that are in red color. 35, 5 times 7, 75, 5 by 5 by 3. This should be 3. Okay, now GCF, take the repeated numbers. Repeated numbers. We have here one column, 5 up and 5 down. We will take only one 5. So GCF here is 5. So the width of each strips is 5 centimeter. She will cut 35 centimeter according to 5 width of each strips. Okay. Homer exercises every 12 days. Rana exercises every 8 days. This is repeated. Something occurs. Okay. Both friends exercise together today. How many days will it be until they exercise together again? Do you have to find GCF or LCM? This is something repeated, so we will need to find LCM. We will write down 12 and 8 and think about 12. What numbers multiplied by each other give you 12? We have 2 by 6 and 3 by 4, whatever, write any one of them. 2 by 6. 2 is a prime, okay, keep it. 6 is not a prime, so we will break it into two numbers multiplied by each other, 2 by 3. Now, our prime numbers are in the red color, 2, 2, 3. Second, we have 8. 8, 2 by 4. 2 is a prime, okay, 4 is not, so we will break it 4 by 2 by 2. The prime numbers are in the red color, so write again 12 with its prime numbers. 2 by 2 by 3. 8, 2 by 2 by 2. Okay, I write this 2 away. because there is no up to here to put it under each other. Now circle the similar factors or similar prime numbers. LCM take from each column the number in it. The first column we have 2 up and 2 down. We need only 2, so we will take 2. And second column we need again 2. And third one we have only 3, we will take it also. And the last column here we have only 2, we will take it. Our numbers 2 by 2 by 3 by 2. We multiply them all together, we will find 24. So they will exercise again together in day 24. Okay? I hope you understand our lesson today and see you soon next session. Bye bye.